Hello students, today we will study about the chapter number 3 pair of linear equations in two variables. This is the chapter of standard 10. In standard 8 you have studied the linear equations in one variable. In standard 9 you have studied linear equations in two variables, and now we will study the pair of linear equations in two variables. Okay. So there are equations with two variables, but there are a pair of equations. That means we have to study here two equations, right? So we will first of all revise that what is the standard form of linear equations in two variables, right? So this is the standard form: ax plus by plus c is equals to 0, where x and y are variables, right? X and y are the variables. That means their value are not fixed. Now what is a, b and c? A, b and c are real numbers, right? That means a, b and c are the constant. Here a is called the coefficient of x, b is called the coefficient of y, and c is called the constant. Right? And one thing here is that a, b and c are real numbers. That means they are either the rational numbers or the irrational numbers, right? Here one condition is there to have this linear equations in two variables. So what is the condition? Condition is that a and b are not both 0. That means at the same time a and b should not be equal to 0, right? So some of the examples of linear equations in two variables are 3x plus 4y minus 2 is equals to 0. Second one is 1 upon 3x minus root 7y plus 0.6 is equals to 0. So here you can see that the coefficient of variable x is 1 upon 3, and this is a rational number. Again the coefficient of y is minus root 7. It is an irrational number, and the constant term here is 0.6, right? That means a, b and c are the real numbers, right? Now what is the meaning of this condition that a and b are not equal to 0, right? Are both not equal to 0. So meaning is that suppose that a is 0, right? So what will happen if a is equals to 0? If a is equals to 0, then this term is not there in the equation. So only there are y and constant terms are there. So this is the example of this. 2y minus 11 is equals to 0. See here, the x is not there because the coefficient of x is 0. So second thing, suppose that b is equals to 0. So now we know that there is not this term there in the equation, only x and constants term is there. So this is the example of this 4x plus 5 is equals to 0. Here y is not there because its coefficient is 0. So why there is both are not equal to 0 at the same time? Because here you can see that for this equation we can draw the graph, right, in the graph paper, and the graph of linear equation is a straight line, that you know very well, right? Now what will happen if only one variable is there? Suppose here if we want to draw the graph for this equation, we know that we get a graph which is parallel to the y-axis, and in this case, as there is only one variable y, the graph of this will be the straight line and it is parallel to the x-axis, right? That you know very well. Now if both a and b are 0, then there is no variable, and if there is no variable, then how can we draw the graph for that equation? Actually it not form any equations, right, if a and b both are equal to at the same time. So this is the condition, right? So I think now this concept is clear in your mind. So now we will study about the pair of linear equations. Okay. So as there are two equations, we cannot take it as A, B and C. So what we will take? C. Here, as there are two equations, we will take it as A1 B1 C1 and A2 B2 C2. So first equation in the standard form is, suppose A1x plus B1y plus C1 is equals to 0, and second equation is A2x plus B2y plus C2 is equals to 0. So in this way we can differentiate the two equations, right? So basically there are three cases for two lines. What will happen if we draw the graph for both the lines? Now you know that this is a linear equations, so the graph of this equation is a straight line. Again, the second equation is also a linear equation and its graph is also a straight line. So there are three cases possible for the two straight lines, right? So the very first case is this. See the graph. Suppose this line is of first equation and this line is of second equation. Here we can see that both the lines intersect in one point, and that intersecting point is, suppose, xy. That means one point is common on both the lines. So how many solutions we can say that? One solution is there. Solution means such x and y, such value of x and y such that it can equivalent both these equations, right? Satisfy both these equations. So this type of lines is called intersecting lines. And one thing here is that intersecting lines are also called consistent pair of linear equations. Consistent, right? So now the second case. Second case that can be possible is that, suppose this line is of first equation and this line is of second equation. Now here we can say that both the lines are not intersecting lines. So there is no solution. That means any point which is common in both the line is we cannot find here, right? So this type of lines are called parallel lines, and parallel lines are also called inconsistent. That means this type of lines are called inconsistent pair of linear equations, right? Third case, see here this is a line of, suppose, first equation, and second line is also here on the first line. So this type of lines are called coincident lines. Coincident line means one line upon another line, right? And this type of lines have infinite solutions. That means every point on the first line is on the second line, right? So this type of lines are called dependent pair of linear equations, right? And dependent pair of linear equations are also consistent pair of linear equations, right? So these are the three cases. Let's revise quickly. There are three cases are possible. One is intersecting lines. Intersecting lines are also called consistent pair of linear equations. Parallel lines. Parallel lines are called inconsistent pair of linear equations, and coincident lines. Coincident lines are also called dependent, and dependent pair of linear equations are consistent pair of linear equations. Here we get one solution, here we cannot get any solutions, and here we get infinitely many solutions, right? So this is the all about this. introduction of this chapter. Now the method to solve this type of equation we will study in the next lecture. Okay? Thank you.